Okay, so we're going to do 21.4. So this is a very basic problem of trying to find the optimal production for the firms, okay, in a general equilibrium. So here we have basically two firms. One is the bakery and the other one is the creamery, okay. So the bakery is going to be producing B following the production function B. So as a function of K and L. So K over here is a capital and L is labor, okay? So we assume that we are using two inputs, capital and labor, in order to produce B units of output for the bakery, following the functions KB to the power a third and LB to the power 2/3, okay? So very similar, creamery is going to have a production function C, again as a function of capital and labor KC and LC, equal to KC to the power 2/3 and LC to the power 1/3. Okay, so these two firms is going to be trying to maximize their production, basically following this production function. Okay, given the initial endowment that they are being allocated with. Okay, so each of the firm is going to try to choose the optimal amount input K and L in order to maximize the total level of output B and C they will be able to produce given the initial endowment of a certain level of capital and labor that they are given in the economy. Okay, so that is basically very similar to the consumer utility maximization problems where the consumers are going to be trying to maximize their utility given their budget constraint. Okay, so here it's exactly the same problem where the firms are given a certain amount of capital and labor to begin with, and they are going to try to find an optimal amount of labor and capital they would like to use in order to produce an optimal or produce a maximum amount of B and C following their production function. Okay, now so if the amount of capital and labor that they would like to use at the optimal level are different from the initial endowment that they are given, then basically they can trade with each other in order to reach the Pareto optimal allocation in which each of the firm is going to be using the optimal amount of capital and labor to for their productions. Okay, so that is the problem where the two firms are trying to find out the optimal amount of capital and labor they would like to use, and then they can trade with each other in order to achieve that optimal allocation. Okay, and that optimal allocation is called a Pareto optimal allocation, where each of the firm is maximizing their production function. Okay, so the question asking you to set out a firm's production problem where the total endowment of K and L is divided equally between them initially. Okay, and we're trying to obtain the Pareto efficient outcomes. Okay, so like I said, the firm's problems is basically trying to maximize their production function over here. They maximize the total level of output B and C given their initial endowment of capital and labor. Okay, so firms. Okay, so basically. Okay, so for the bakery. So the firm is basically trying to maximize the total amount of B, which is the total amount output, okay, as a function of KB and LB, which is equal to KB power third, LB to power 2/3, okay, by choosing the optimal amount of KB and LB, right? Now, subject to the fact or to the constraint that they are given half the initial endowment of L and K to begin with. Okay, so basically, whatever amount of K and L they would like to use, or okay, so the total value of the capital and labor. So that is going to be the WK, which is the price of capital, multiplied by the level of capital they would like to use, plus the price of labor, which is WL, times the total amount of labor they would like to use for their production. So this is basically the total cost, okay, of inputs that they will have to incur in their production. Then it has to be equal to their basically to their income. Okay, so it's very similar to the consumer's problem, where the total expenditure that has to be equal to the total income. So in this case, the total cost of production, which is the thing on the left-hand side over here, it has to be equal to their total sort of income to begin with. Okay, now their total income is basically given from their initial amount of capital and labor that they are given from the beginning. Okay, so initially they are given half of the capital and half of labor. So each of the firms share the endowment equally. So therefore, initially, the value of the inputs they have is the price of capital times the total amount of capital that they have, that the firm has, which is half of K. Okay, and the price of labor times the total amount of labor they have from the beginning, which is half of L. Okay, so each firm share basically the total initial endowment equally. Right, so I'll say each firm initially has half of K and half of L. Okay, where K is the total amount of capital available in the market and L is the total amount of labor available in the market. Okay, so this is basically the total cost for the firm by producing B, okay, by choosing the amount of KB and LB, and this is the total income or the total value that the firm has from the beginning. Okay, so this is basically our problem. So again, now if you want to set out a Lagrangian function and try to find the first order condition to maximize, this is totally fine, okay? However, you can also apply the optimal condition that we already learned before, okay? So the optimal condition is basically where the marginal rate of technical substitution for the bakery, okay, which is basically equal to the negative of the marginal product of capital divided by the marginal product of labor, okay, or marginal product of labor divided by marginal product of capital. That is fine, okay. So we studied this before. It has to be equal to the negative of the input price ratio, which is WK on WL, okay. So again, remember, I did mention this before. If you put K on top, it has to be WK on top on the right-hand side, okay? Or if you put L on top, and it has to be WL on top. Okay, so this is basically the optimal production conditions in order for the firm to be maximizing their level of output, okay? All right, so what we have to do is just to find a marginal product of capital and marginal product of labor. Okay, so marginal product of capital for firm B, it's just going to be the differential of their production function, which is B, with respect to amount of capital K, B. Okay, so if I differentiate the production function here with respect to KB, I'll get 1/3 KB to the power negative 2/3 and LB to the power 2/3. Okay, so we're treating LB as constant. So very similar marginal product of labor for firm B is just the differential of the production function with respect to LB. And I'll get 2/3 KB 1/3 LB to the power negative 1/3. Okay, so therefore the marginal rate of technical substitution for firm B is just going to be equal to the negative of the marginal product ratios. And that is just 1/3 divided by 2/3 will give me a half. Now KB negative 2/3 divided by KB negative 1/3, or I just write down the 2. So I got negative 1/3 KB LB 2/3 and everything divided by 2/3 KB 1/3 LB negative 1/3. Okay. All right. So negative 1/3 divided by 2/3 will give me negative half. KB negative 2/3 divided by KB third is going to give me KB on the denominator. Okay. And LB 2/3 divided by LB negative 1/3. So if I move LB negative 1/3 to the numerator, that will become LB to the power 1/3, and multiply by LB to the power 2/3 will give me LB. Okay, so this is my marginal rate of technical substitution, and if I equate this to the capital, to the input price ratio, okay, so then I'll call this is the star condition, is negative half LB on KB. It has to be equal to negative WK on WL. Okay, so this would just give me, so if I do cross multiplication, then I'll get WL times LB. It has to be equal to 2 WK times KB. Okay, so if I do cross multiplications, I'll get this. Okay, so instead of using star over there, okay, just use star, it's fine. Okay, so I'll call this is the first condition, okay? Now, so in order to find the optimal amount of L and B, so L and K, I would just have to substitute these back into the budget constraint, okay? So into the constraint over here. Into the constraint for the firm. So, so what I got is WK times KB plus WL times LB, and that is just going to be equal to 2 WK times KB. Okay, and so it has to be equal to the right hand side over here, which is equal to half of WK times K plus WL times L. Okay, so so this will give me 3 WK KB, and it has to be equal to half of WK times K plus WL times L. So therefore, KB is going to be equal to, so 1/2 divided by 3 is 1/6. WK times K, WL times L, and everything divided by WK. Okay, so this is the optimal amount of capital that the bakery would like to employ in order to maximize the firm's production, okay, to maximize the firm's output. So if we are given the amount of the initial total amount of capital, total amount of labor, and the input prices WK and WL, we should be able to find this optimal amount of capital that firm B would like to use, okay? So after finding the amount of KB, if you substitute this KB star back into the first condition over here, you should be able to find the optimal amount of L for firm B. Okay, so from here we know that WL times LB is equal to 2WK times KB. And in this case, KB is 1/6. So I would say this is L star, okay, which is the optimal amount of labor. WK times K, WL times L, and everything divided by WK. Okay, so WK and WK will cancel out. 2 times 1/6 is going to be 1/3. WK times K, WL times L. And so therefore from here, I should be able to find that LB star is equal to 1/3 of WK times K, WL times L, everything divided by WL. Okay, so this is the optimal amount of labor that firm B would like to use in order to maximize the firm's output. Okay. So a very similar problem is going to be applied for the greenery. Okay. So again, the firm would just like to maximize the firm's production function C as a function of Kc and Lc, which is equal to Kc e power 2/3, Lc power 1/3. Okay, and subject to the constraint that, again, just the total amount, the total expenditure, the total cost has to be equal to the total income. Okay, so again, WK times KC plus WL times LC, it has to be equal to, again, WK. So the greenery, again, given half of the initial endowment. Okay, so all right, so the problem is going to be very similar, where we just have to find the marginal product of technical substitution and equate that to the price in the input price. Okay, so optimal solution is where the marginal rate of technical substitution for firm C has to be equal to the input price. So negative marginal product of capital C, marginal product of labor for C, equal to the WK on WL. Okay, so if you differentiate the production function with respect to K and L to find a marginal product, you will get 2/3 Kc negative 1/3 Lc 1/3 divided by 1/3 Kc 2/3 Lc negative 1/3. Sorry, negative 2/3. Okay, and that has to be equal to WK and WL. I'll just get rid of a negative sign on both sides of this equation, okay, which is fine. So 2/3 divided by 1/3 is 2. And I got LC on KC equal to WK on WL. So therefore, again, doing cross multiplication, I'll get 2 WL LC equal to WK KC. Okay, so call this is the second equation. Okay, so if I sub this second equation into the firm's constraint above, then I get, okay, so WK times KC is just equal to 2WL times LC plus WL times LC equal to half of WK times K plus WL times L. So therefore 3 WL times L is half of the WK times K plus WL times L. Okay, so from here, you should be able to find out that L star, which is the optimal amount of labor that from C would like to use, is 1/6 of WK times K, WL times L, everything divided by WL. Okay? And again, if I sub the value of optimal labor into the second condition, then I'll be able to find the optimal amount of capital. Okay, so I've got 2 WL times LC, which is 1/6 WKK WLL, everything divided by WL. Okay, and that has to be equal to WK on KC. So WL will cancel with WL. 2 on 1/6 is 1/3. WKK WLL, and that has to be equal to WK times KC. Okay, so from here, I'll be able to find the optimal amount of capital from C would like to use, which is 1/3 of WKK WLL, okay, divided by WK. All right, so we're done. All right, so the problem 21.5 is just basically the specific case of 21.4 where you are given the numbers. Okay, so if you are substituted endowment amount of capital and labor into the problem, then you should be able to find the result. Okay, so if you are doing 20.5, it's just going to be the practice of 21.4, just to give you more exercises to get used to the problem. Okay, so instead of having a general value of the initial endowment, which is just half of the K and L, you are given a certain number for the initial endowment, but the problems are going to be exactly the same thing. Okay, so try to practice with problem 21.5.